My name is Keshwani. That's Keshwani. Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 800. Please turn to it, page number 800. And today is our lesson number 105. There are two problems there on page number 800, 15 and 16. They are both hard ones. But before I do problem number 15 and 16, I want to go back to what we did yesterday, problem number 14. Problem number 14 on page number 799 that we did there. I wanted to make a comment there and I forgot all about it and I closed the video. Here's what I want you to do. I want you to watch yesterday's video, which is day number 104, and then I want you to compare this question that you see here, number 14 on page 799. I want you to compare it with number 11 on page 612 that we did on day number 58. And you will get something out of it. Compare the two problems and see the similarity between the two problems. And if something like this appears again in your exam, you will have a much better idea having seen these two problems next to each other and having gotten practice on both of them. Let's go on to the next page then, page number 800. On page number 800, you see number 15 that we are about to do. Again, I want you to compare this problem with number 16 on page number 548. Something that we did on day number 45. And again, by doing the two problems next to each other, you will see how the same concept can be presented in a slightly different manner. Okay, let's take a look at it here. Here's what's given to us. We're given a box here. Actually, it's a cube. We're told that it's a cube of length 2, which means all the sides are equal. So let's draw our cube as best as we can. There is our cube. And the question is, now here's the question. We know that it's a cube of length 2, which means this side is 2, this side is 2, all the sides are 2. And they're showing 2 points. Point A right here, and point B is located right here. What is the question asking? The cube shown above has the length of has edges of length 2, which you already know that, and A and B are the midpoints of the two edges. Alright, so we know that A is a midpoint and B is a midpoint, which means from here to here, let's give this point a name, let's call it C. From A to C is 1. And similarly, let's call this point a name, let's call it D. B to D is also 1. B to D is also 1. Question is, what's the length of AB? Now listen very carefully. It is a tricky question. In order for us to find the AB, right here is the AB. I'm going to put it in a different color so we can see it. In order to find AB, I don't know if you're able to see that the difference in color it's a red ink. In order to find the distance AB, we first have to find A to D. What I want you to understand is that the triangle, this triangle that is sitting on the floor, ADC, triangle ADC is a right angle triangle, where A to C is 1, C to D is 2, and A to D is what we need to find. Now once we find A to D by using Pythagorean theorem, we're going to have to use the Pythagorean theorem one more time by looking at the triangle ABD. And in triangle ABD, angle D is a right angle. Here, angle C is a right angle. I'm not going to put it here, well perhaps I should. This is a right angle. It doesn't look like a right angle because it is sitting on the floor. I shouldn't have done it now because now it looks a little ugly. I should have left the good enough, well enough alone. There. So that's what we have to do. First we have to find A to D, which is a hypotenuse. Listen very carefully. Okay. A to D, which is the hypotenuse of the triangle ADC. But then once we find the length of A to D, that hypotenuse actually becomes the base of the triangle ABD. And in triangle ABD, the hypotenuse is A to B. In which case B to D is 1, B to D is 1. Once we find A to D, we'll have our base, and we're going to use Pythagorean theorem one more time and find A to B. Tell you what, I have an idea. Why don't you, now that you know what's going on here, now that you have a little bit of a better idea, it'll be fun for you to pause the video and do what I just said and see what you come up with the answer, and then continue and resume the video and compare your work against the work that we are about to do together. Alright? Let's do it together then. So here's our triangle ADC. ADC, the triangle looks like this. Here's our point A, which is right here. This is our point C, and A to C is 1, and C to D is 2, and then C to D is 2, and A to D is what we are trying to figure out. Let's call it x. So x squared equals 1 squared plus 2 squared, which is 5, and therefore x is square root of 5. X is square root of 5. That's it. We know now A to D is square root of 5. A to D is square root of 5. We're done with it. That's it. It's over. It's done. Okay, I need to erase it. Now, look at triangle ADB. ADB, where A to B is the unknown, which is the hypotenuse, which is what they're asking for. B to D, we know B to D is 1, and A to D we just found out was square root of 5. That's all. So one more time, A to B, I'm not going to call it X because we used up the symbol X to represent A to D, so let's call it Y here. So Y squared, which is what A to B is here, A to B is what I'm calling Y. Y squared would be 1 squared plus the square root of 5 squared, which will simply be 6. And therefore, Y is square root of 6. Y is square root of 6. There you go, answer choice D. And that's it. That's it, we're done. So the concept that is needed here is a very simple concept of Pythagorean theorem. You have to apply it twice. So the concept itself is actually obviously very simple, but it's a tricky question. You have to understand what's going on in terms of the spatial ability that you need to have in order to see the three-dimensional things, which is why it's important that you compare this problem that we just finished with the one that I already told you about, which is number 16. You see, it appears in the same section, a section of 16 question, but in that section it appeared in question number 16, again a hard question. Here is appearing in question number 15. It's the exact same thing, whether it's 15 or 16, there is no difference there. It usually appears in this part, this area of the exam, something like this. And do that problem and do this problem back to back. All right. Let's move on to the next one, number 16. Enough said. Let's go to next number 16. Number 16. The tea bag just falls over sometimes, all of a sudden, and it spills tea on you. Alright, number 16. We are told that when we see the symbol here, X in the symbol here, we are to follow these instructions. And that's what they are. These are a set of instructions. And how do we read this thing? Don't sit there and read this thing as x in this circle equals that. That doesn't mean anything. Read it as instructions. What we are told here is that whatever we see in this circle or oval, whatever it is, doesn't make any difference whether it's circle or oval or square or triangle, whatever it is, we have to square that quantity and then subtract from it the quantity that we see in the circle. And the question is, how much is, we are told that this quantity equals this quantity. And the question simply is, what is A? What is A? Well, let's find it. A, if we have A in a circle, we just replace x with A and we find A squared minus A. And now we have, in the next one that we have is, I keep calling it circle, but of course it's not a circle, it's more like an oval, but it doesn't matter, as I said. A minus 2. Again, all we have to do is go back to our original instructions. We are told that whatever we see in the oval, we have to square it and subtract from it whatever we see in the oval. So that's what we're going to do. So in the oval now we have A minus 2. So we're going to square it. A minus 2 squared minus A minus 2. And we are told that these two quantities are equal to each other. So that's what we're going to do. We're going to equate to each other. We're going to write them as an equation. So there we go. We're going to erase everything here. We're going to write this quantity here. A squared minus A. Because A squared minus A part is the A in the oval, and this is A minus 2 in the oval. There you go. So open the parentheses here, we get A squared minus 4A plus 4. That's what the first part is. And then here we have A minus 2. And here we're going to get A squared minus A. All we have to do is simplify it now. So we get A squared minus A equals A squared minus 4A plus 4 minus A. See, there's a minus outside, minus and a minus, it's going to become plus 2. Now what do we see? Well, I see A squared on this side. I see A squared on this side. If we were to subtract A squared from both sides, I shouldn't have to show you the baby stuff here. I mean, it's going to be gone. Actually, I'm not going to show you the baby stuff. You already know that. We subtract A squared from both sides, and A squared drops out. Similarly, we see a negative A here, and we see a negative A here. So that drops out. What are we left with? We are left with, on this side, we are left with 0. And we are told that equals minus 4A, and then here we have positive 4 and a positive 2. This positive 6. Bring 4A to this side. In other words, add 4A to both sides. I just told you I wasn't going to show you the baby step, and I did it again. So negative 4A and a positive 4A is going to drop out, and 4A equals 6. 4A equals 6. That's it, we're done. Therefore, A equals 6 over 4 or 3 over 2. 3 over 2. And the answer is C. The answer is C. And that's all there is. That's how simple it is. I will see you tomorrow, where we'll begin the next exam. Today was our day number 105. And as I've explained to you many times, there are 3 sections in each exam, 3 math sections in each exam. It takes me 5 videos to make one section, to finish one section. Therefore, I do one exam in 15 videos. Today being 105 is the end of the 7th exam, because 15 times 7, 15 times 5 is 75, 75 plus 30 is 105. So today is the end of the 7th exam, unless I made a mistake in my calculation. Tomorrow we'll start exam number 8. In other words, 7 down, 3 to go. So in 45 more days, in 45 more videos, we'll be finished with this entire book. Alright? Which was the plan when I first started this project almost 2 months ago. I will see you tomorrow, okay? Bye now.